Assalamu alaikum wa rahmatullahi wa barakatuh. Hi guys, how are you? This is Science Lessons Grade 3, and today we're gonna talk about Chapter 2, Lesson 5, What is Sound? Again, Lesson 5, What is Sound? This is page 61, and as you know, we already talked about sound in the Grade 2. Sound happens when something vibrates. What's the meaning of vibration? You remember? Yes, move back and forth very quickly. Good job. So vibration is a back and forth movement. Okay, so let's watch this video to know more about the sound and how does sound travel from one place to another. Let's watch together.
Bubbles, can you bring me my bag? Where is my bag? Why did you not bring my bag, Bubbles?
I couldn't hear you, Spiky.
But I called you so many times.
Oh, maybe because your sound did not travel to Bubbles.
What? Does sound travel?
Yes, sound travels. But how can sound travel? Sound is a form of energy that spreads from its source in all directions. We hear sound when vibrating particles hit our eardrum. Sound moves when the particles hit each other and pass on the vibrations.
Okay guys, so as you know, sound is made when something vibrates. And when something vibrates, you can hear the sound. How? Sound is traveling, as you see, from this place to your ear. How does sound travel? As waves. And this is a sound wave, as you see. We're gonna call it compression waves because it have some spaces that particles are far away and some spaces that particles squeezed or closed together. Okay, so this is a sound wave. And when the sound wave hit the particles, what happened? Particle move and hit each other. As you see, particles hit each other and carry the sound from this place to another place. Let's continue.
That's right. Sound needs a medium for its propagation.
So, if there is no medium or no matter, sound cannot travel. How? Sound need a matter to travel through it. So sound can travel through solid matter like wood or gas like air or liquid like water. So sound need some matter to travel through it. Teacher, if there is no matter, sound can travel? No, of course not. So, if you go to space, maybe sometime, you can't hear anything. Why? Because no matter in the space, no air and no matter, so sound cannot travel. That's why you can't hear the explosions on the sun's surface. Why? Because there is no matter, so sound cannot travel from sun to our earth. Excellent. Okay, let's continue.
Medium may be a gas, such as air, a liquid, such as water, or a solid, such as metal. Do you recall the last time you saw lightning? You saw the flash of lightning first and heard thunder only a few seconds later.
But why did you see lightning first?
Yes, guys, why do you think we see lightning first, then we hear the thunder? Why do we see the lightning before we hear thunder? Do you know? Yeah, we see the light, hear lightning, then we hear thunder. That's because, yeah, super, light is faster than sound. Good job. So, sound travels slower than light. Light is the fastest thing in the whole universe. It's so fast. Okay, that's why we see the lightning, then we hear the thunder. Let's listen together.
The speed of light is almost 1,000,000 times faster. Sound travels more slowly than light in air, so sound takes longer to reach us. The speed of light is almost 1,000,000 times faster. Air is made up of gases. The particles in gases are farther apart than in liquids or solids. It takes longer for one gas particle to hit another gas particle and move the sound energy along. Sound can travel through other mediums than air. In fact, in water, sound travels faster and can travel further. Particles in water are closer together. That's why sound travels more quickly in water than in air. Sound waves travel even better through solid things like wood or metal. The particles in a solid are tightly packed, and sound waves travel fastest in this medium.
Okay, guys, so now you know that there are three states of matter: solid, liquid, gas. Okay, so which one is the fastest? Which one can carry sound or help sound to travel fastest? Which matter can help sound to travel fastest? Solids. Excellent. That's why, because particles of solids are close. Excellent. Close to each other. So they can hit each other faster and carry sound faster. Liquid, the particles is, as you see, farther than solids. So they can carry or help the sound to travel slowest or slower than solids. Then gases. As you see, gases particles are far away from each other. So they take long time to hit each other, so they can carry or help sound to travel through it. So gases is the slowest matter that can help sound to travel. Okay. So we have three different matters: solids, liquids, and gases. Which one can help sound travel fastest? Solids. And which one helps sound travel slowest? Gases. Good job. Okay, let's now move to the next part.
About how sound travels in solids. Tap your desk with your hand and listen to the sound it makes.
Okay, guys, come on. Tap your desk.
Here on your desk and tap the desk again.
What do you hear?
Did you notice a change in sound? Which one was louder?
Okay, can you tell me which one was louder? When you put your ear on the desk or when you hear the sound and yes, in this picture. Let's see here. On the desk. Excellent. That was louder. Okay.
The one that I heard by putting my ear on the desk.
The sound is louder because the sound vibrations travel faster through solids than in air. When you heard the tap the first time, sound waves traveled through air. But when you put your ear on the desk and heard the tap,
Yeah, sound waves travel through what? Here. What? Excellent. And what is solid? Good job. Super. Let's continue.
the sound waves travel through the desk, which is a solid. In outer space, you can't hear anything because there is no air or any other matter. We call this a vacuum.
So guys, again, if you go out to the space, you can hear the sounds. Can you hear the sounds? No, of course not. Why? Because there is no matter, no air in the space. So, sound cannot travel through space. Okay, let's continue.
So there is no medium that sound can use to travel. When you see a spaceship explode in space, you don't hear a thing. How fast does sound travel? In air, sound travels with a speed of approximately 350 meters per second. But sound travels faster in liquids like water and fastest in solids like wood. Time for an exercise. We put a cell phone in a jar and hang it mid-air by a thread. We pump the jar vacuum and seal it.
Okay guys, so this jar have no air inside it. And you will try to call this cell phone. You will try to call this mobile. And you will hear nothing. The mobile ringing and you can't hear it. Why? Because there is no matter. Excellent. No matter for sound to travel. Excellent. Let's continue.
Make a missed call for the cell phone inside. Do you hear the ringtone of the cell phone? No, we cannot hear the ringtone of the cell phone. We removed all the air from the jar and created a vacuum. We confirmed that sound cannot travel through a vacuum. Let's summarize.
Okay guys, so let's move to the booklet page 61. Again, you already know sound happens when something vibrates. What's the meaning of vibration? To move back and forth very quickly. Okay, if you try to make a sound box like we made in the class, a sound box, you bring a box, you put a strain on this box and you try to stretch the strain and you can hear a sound. Excellent. Let me show you this experiment. Okay guys, if you bring a box like this and you put the strings on this box, okay, let's see what we gonna hear.
What can affect the sound made by a rubber band? Listen carefully. Let's add a ruler. Listen.
So guys, this is the vibration when this band moves back and forth very quickly. So this is vibration. Okay, so let's back again to our PowerPoint. So now you know vibration is a back and forth movement. Some sounds are loud and some sounds are soft, like when you whisper. This is soft sound. Some sounds are high and some sounds are low. We're gonna talk more about this in the next session. How sound travels. Sound can travel only through matter. We already mentioned this. Sound cannot travel through space. You know why? Sound travel in waves which spread out in all directions. Sound waves lose energy as they travel. Okay. So, sound waves are compression waves. What's the meaning of this, teacher? We mentioned this before. Compression waves means there are spaces in which particles are squeezed together or so close together, and the spaces, as you see, spaces where particles are spread out far from each other. So this is a compression waves. Again, compression wave. Spaces in which particles are squeezed together here, and spaces where particles are spread apart. So how can we know the wavelengths for this wave? Its wavelength is measured from the center of one compression to the center of the next compression, or the center of this part where the particles away from each other do, yes, excellent, the center of the part where the particles are away from each other. Excellent. So this is the wavelength. Sound travels through solids, liquids, and gases. You already know that sound travels the fastest through solids, because solids particles are closer together. Good job, guys. Okay, let's now talk more about echo. What's the meaning of echo? Let's watch the video to know what is echo.
What was that sound? Hello?
Okay, guys, in this part, you think there are someone talking or just this mouse? Yeah, just this mouse. So what happens? It's the echo. What is echo? When sound hit the wall and bounce back. What's the meaning of bounce back? Let's watch and see. Yes, like this cube. You see this cube? Bounce back. Come back again to this mouse. So the sound do like this cube. Excellent. Bounce back. Hit the walls and bounce back to the mouse. So the mouse here his sound again. Let's continue.
Yes. What are you doing, Ham? Someone just threw a rock at me. Look there. Ah, Ham. It is your echo. Watch. Echo. It seems like another star is talking back, but this is called an echo. The sound waves leave your mouth, travel through the air, and hit a hard surface, and then bounce back, causing you to hear the sound again. Echoes can usually be heard in caves, where a lot of hard surfaces are around you. Hello? Handsome.
Okay, guys, now you know what what is echo? Let's move back again to this page 63. Echo happens when sound waves strike an object and bounce back. As you see, strike an object and bounce back. Sonar equipment uses echoes to study the ocean, so they use sonar equipment to know how long it takes for sound to bounce back, so they can measure how deep is this ocean. And some doctors can use sonar equipment too to know what's inside a human's body. Okay guys, so let's continue. This is page 64. We talk about volume. Volume is how loud or soft sound is. So sound can be loud like this or soft like when you whisper to someone. So volume depends on two things: how much energy sound has. So if the sound had a lot of energy, it will be loud sound like this picture. It's a loud sound. But if sound have little energy, it will be soft like when you whisper to someone. Okay, this is the first thing. Second thing, how far away a listener is from the source of the sound. So this boy here is closer to the ambulance, so he can hear a loud sound. But this boy far away from the ambulance, so he listen soft sound. Excellent guys. So I'm gonna send you this video, you can watch it at home. Let's now write the new words together. First word, back and forth movement. As you see, back and forth movement. Can you tell me what is this? Volume or vibration? Vibration. Good job. Okay. Word number 2. Spaces in which particles are squeezed like this together, and spaces where particles are spread apart like this. Squeezed, spread apart, squeezed, spread apart. So this is light wave or compression wave. Compression wave. Good job. Let's clap for you. Word number 3 is measured from the center of one compression to the center of the next compression. The center of one compression to the center of next compression, like from the crest to the next crest. So this is wavelengths. Good job. Okay, last word, happens when sound waves strike an object and bounce back, as this man tried to say hello. And hello, hello, hello. This is echo. Good job. Okay, I'm sorry. This is the last word. How loud or soft sound is? Volume. Good job. And this is all for today. Thank you so much. See you next time, inshallah. Bye.